Hello everyone, for this tutorial video I like to explain how a simple parallel combination of one capacitor and one inductor specifically works, and this is called a tank circuit because of how it looks like a fish tank sort of when you look at the schematic of it. An interesting thing happens when the reactance of the two components are identical. Namely, the signal will be at its strongest compared to other frequencies, because of the fact that at any other frequency, the reactance of one component would be greater than the other, so the overall signal would be weaker. And the technical term for this perfect spot is called resonance, exactly like what resonance means with mechanical systems. Or in non-technical language, if you know that something resonating with you means that you feel it stronger compared to other things. So since we know resonance occurs when the two reactances are exactly equal to each other, we would use the appropriate formulas and set them equal relative to each other. Then attempt to get the frequency by itself by first multiplying the left-hand frequency by the right-hand frequency to get frequency squared on the left-hand side. Get frequency squared by itself by dividing the right-hand side by 2 pi times L. And then finally, conclude that the frequency is exactly the square root of everything, which upon simplifying is 1 over 2 pi times the square root of LC, because of how the square root of 1 is 1, and the square root of 2 pi times 2 pi is simply 2 pi by basic definition of the square root. So next, if we calculate the impedances at the resonant frequency, we see that they are equal as predicted. And then we would use the parallel impedance formula we know to be true for parallel circuits in general, and conclude that we get an infinite impedance, so we get a minimum current or zero current. So it is interesting to observe that even though the signal is strongest at the resonant frequency, the current is exactly zero, as the math shows. In my next tutorial video, I like to talk about series resonance instead of parallel resonance as discussed in this video. And then after that, transition to a discussion of how motors work, which are important in the design of electromechanical objects, such as robots, fan motors, or motors in car engines. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.